So this is problem number 12. So the radius of a circle inscribed in any triangle whose sides are a, b and c is given by this expression, that is x minus a into x minus b into x minus c divided by s whole square root. And we are asked to find whether this formula is correct or not. So inscribed circle means that a circle which is inside a triangle and it touches all the sides of the triangle. So we are given this formula where s is equal to a plus b plus c divided by 2, and we have to check its dimensional consistency. So let us first check the dimensions of this s. Since a, b and c are the sides of triangle, so it means they have the dimensions of length. So L plus L plus L gives us the dimensions of L, because only those quantities can be added or subtracted whose dimensions are same. So S has dimension L, and now let us check the dimension of this s minus a, s minus b and s minus c. Since we know the dimensions of s is L and the dimension of a is also L, so s minus a will give me L, because only those quantities can be added or subtracted whose dimensions are same. So this s minus a has dimensions of length. So for s minus a, s minus b and s minus c, I can write this expression L into L into L and divided by s, and the dimension of s is L. So 1 L will cancel out with 1, so I will left with this L squared, but since we have to take its square root, so after taking its square root I will left with only L. So on the right side of equation I have the dimensions of length, and obviously this r is the radius of the circle and radius is distance, so distance has the dimensions of L. So it means both left and right sides have the dimensions of length. So this formula is dimensionally correct. Problem number 13. The displacement s of a particle is given by this expression, which is equal to k a raised to power m and t raised to power n. And we are asked to show that this expression is only true for m is equal to 1 and n is equal to 2. So this is the problem. So this is the formula which is given: s is equal to k into a raised to power m into t raised to power n, where k is dimensionless, k does not have any dimensions. So on the left side the dimension of displacement is length, and on the right side we have two quantities who have dimension, that is acceleration and time. Since the units of acceleration are meter per second squared, so it means the dimensions are length per t squared, length over time squared. So for a I can write L over t squared, and since the power is m, so I can put this power on both quantities, so this will become L over t squared whole power m. And for the dimension of t is capital T, so I can write as t raised to power n. So further I can shift this t squared, so this will become L raised to power m and t raised to power n minus 2m. So this formula is not true for any values of m and n. So we see on the left side we have L raised to power 1, and on the right side we have L raised to power m. So this implies m is equal to 1. Similarly on the left side we do not have t, so it means on left side we have t raised to power 0, and on right side we have t raised to power n minus 2m. So this is equal to n minus 2m is equal to 0. Since m is equal to 1, so this will give me n is equal to 2. So putting these values in the above expression, I get s is equal to k a t squared. So this formula is dimensionally correct. So from there I can find the value of k, which is equal to s over a t squared, and this is of course dimensionless. Problem number 14. So in this problem the time period of a simple pendulum is given, the relation for time period is given, and we are asked to check whether this formula is dimensionally correct or not. So we can see that this is the formula, and on the left side we have dimensions of time, and on the right side we have 2 pi. So 2 pi does not have any dimensions because it is a number, so we have only L and G. So L is of course length, it is given in the question, so in the place of L I can write this capital L. And it is also given in question that the dimensions of this free fall acceleration G is equal to L by T squared. So I can put the value of G, I can put the dimensions of G. So this is L divided by T squared. So L cancel out, and I get this expression. So it will, in taking its square roots, it will give me T. So dimensions on left hand side and right hand sides are same. So this formula is dimensionally correct. Problem number 15. So in this problem, two equations are given and we are asked to find whether they are dimensionally correct or not. So this is the first equation, that is v is equal to v naught plus ax. So where v and v naught are the velocities, and a is the acceleration, and x is the displacement. So let us put the dimensions and check. So dimensions of velocity is L by t. So we can put L by t is equal to L by t plus. So the dimensions of acceleration are L by t squared, and the dimension of displacement x is L. So I can write this expression. So further, L by t is equal to L by t plus, because I can shift this L into L is equal to L squared. So I can write L by t whole squared. So now you can see here that there are two terms which are being added, but they don't have the same dimension, L by t plus L by t squared. So these two quantities don't have the same dimension, so they cannot be added. So it means this formula is dimensionally wrong. So we can correct this formula. If I put a square root in this quantity, then the dimensions of these two quantities will become same. So this will have L by t plus L by t. So all those quantities who have the same dimensions, when they are added, they give the same, their sum will have the same dimensions. So this will be correct. So now this is a correction, that is v is equal to v naught plus ax square root. So in the second formula, it is asked to check the dimensions. So y is the displacement, and next we have 2m. M here stands for meter, and further we have cos kx. So let us put the dimensions. So the dimensions of y is length, and next we have 2m. 2 does not have any dimension, it is a number, but meter stand for length. So I can write here L, and further we have cos kx. Please always remember that the arguments of trigonometric functions like cos, sine, and tan, and further exponential functions, they are always dimensionless. So this factor does not have any dimensions, so L becomes equal to L. Further, you can see here the in the question the dimensions of k are given, which is the inverse meter or inverse length, and the dimension of x is length. So length into length inverse is equal to 1, mean there are no dimensions. So we can also check in this way. So this formula is dimensionally correct. Problem number 16. So it is a very simple problem. The Newton's law of universal gravitation is represented by this formula, and we are asked to find the units of this gravitational constant G, while all other units are given. The units of force, masses, and are given. So this is the formula. So let us put the units of all quantities. So units of force are given, which is kg meter per second squared, and next is equal to units of G. Further we have masses, so kg into kg divided by m squared. So after cancellation, kg will cancel out. So on the left side I will have meter second squared, and on the right side I will have units of G into kg by m squared. So shifting the variables from right hand side to left, I will get units of G is equal to meter cube divided by kilogram second squared. So these are the units of this constant g.